Normal to a plane. We need a normal when we want to find the equation of a plane, or if you want to find the angle between the plane and the line. So your ability to find the normal is very important to help you to solve problems. To find the normal to a plane, you need two vectors. Let's say you have vector A and vector B. The two vectors must be lying in the plane. The cross product between vector A and vector B will produce a new vector that is perpendicular to vector B, perpendicular to vector A. Of course, at the same time, A cross B, this vector is also the normal to the plane. Doesn't matter whether you use A cross B or B cross A, just that the B cross A is at the opposite direction. Don't need to worry whether the cross product that you find out, whether it is going up or going down, doesn't matter. So to find the normal to the plane, you need two vectors. If the two vectors are given in the proper form, like the diagram, you have no problem to find the normal. However, in our exercise, most of the question, the two vectors that you need to find the normal are usually hidden some way. You have to find out indirectly. We will look at this case by case. Case number 1. Now you have 3 points on the plane. So meaning that you know their position vector. So to find the normal to the plane, you need two vectors. With these 3 points, you can find more than two vectors if you want. So the first one, let's say if you want to use the vector PQ and PR, then it will produce a normal. Or if you have time, you can find, let's say, RP and RQ. You can also use this pair of vectors to produce another normal. Don't need to worry about the direction. You can going up or going down. We do not know. After you calculate, then only you know by doing the comparison. Or you can use Q, P, and QR to produce another normal. Now, I want to ask you, do you think all the normal here, N1, N2, and N3, are they the same? Are they equal? The answer is no. They are not equal. They are different. Only the direction are the same. Let's say maybe n equal to 2 times of n2 or 3 times of n3. They are parallel, but their magnitude can be different. So remember, when you compare your answer with your friend or from the answer from the books, sometimes have different magnitude. You just need to check the direction. Are they the multiple of another one? But you must remember also, when you use this cross product, still remember what is the definition of cross product? This is the one. So you actually, in cross product, we need to consider the angle between the two vectors. So if these 3 points given, if they are collinear means all these points lie on the line, a straight line, then they are parallel. So the angle is 0. When 0, this cross product will produce a 0 vector. So you cannot use these 3 points to find the normal if they are collinear. Now, case number 2, now you have a point, okay, a point on the plane, and also an equation of the line. The line lies in the plane with this equation. So the line is in the direction vector B. So to find a normal, you need two vectors. You already have one vector, vector B. Another one, how? So what you need to do is you must find at least one more point here on the line. One more point at least. So how to do that? So you can substitute any value, 0, 1, or 2, to get another point, or 2 points, up to you. So when you have the, let's say you have the point here, by substitute t equal to 0 or 1 or 2, you can get how many points? How many points? Up to you, 2 or 3 or 1. Then, since you need two vectors, you need to find vector PE. So with vector PE, with vector B, you can start with your cross product to find the normal. Okay. Of course, not only this, you can also use, let's say you want to use, don't want to use the B given, you can use, calculate your own vector EG. You can also do the cross product to produce another normal. Case number 3. Now you are given two equations, two equations of the line. So from the equation here, you can identify the direction of the line. They are B1 and B2, the direction of the line. So you already have two vectors. So you have two vectors, you can carry out the cross product to find the normal. So don't need to worry about the line here. They seems like they don't meet. So can we still use it to perform the cross product? No problem. You just assume that this line is parallel to L1. So you carry out the cross product, you get a normal. Now, case number 4. You only have one information. The parametric equation of the plane is given. No point here, no point is given, no line, but a parametric equation of the plane. So you must understand the meaning of parametric equation compared to the usual equation of the plane. Now, no normal is given in the equation. So the vector BC here, actually any two vectors that lie on the plane. Doesn't matter what is the direction as long as they are not parallel. And since you have two vectors, you can use it to find the normal. So you get the normal here by using the vector B and C from the parametric equation. Now, you are given two parallel planes, and each plane has a line, has a equation of the line. So this line, they are in the direction of B1 and B2. So to find the normal, you need two vectors. The question now is, can we use these two vectors if they are at different plane? The plane are parallel. Can we use it? The answer is yes, if the plane are parallel. So we can use these two vectors b1 and b2 to find the normal. Or you can assume you take b1 down here, then you find the cross product. You can also get the normal. So this normal is parallel to both of the plane. Now, case number 6. Case number 6 and case number 5 more or less the same, except now you don't have the line. Instead, you have points. So each plane, the parallel plane, you have 2 points. So we want to find the normal to the plane. So you need 2 vectors. So you need to spend a little bit of time to find the vector AB and vector CD. So with these two vectors, you find the cross product, you will get the normal. You can assume that CD is here, this line, this dotted line parallel to CD, then you can find the normal. Or you can assume this dotted line is parallel to AB, the product will give you the normal. Now, case number 7. Now, it is given the equation of a line that is perpendicular to the plane. So you have an equation like this, you know it is perpendicular to the plane. What is the normal? So you can straight away use the direction vector here, b1, take it, assume it as the normal to the plane.